Hello people, welcome back to my programming series. Today we're going to take a look at solving a computer science problem. So maybe you're going to do an interview, or maybe you're new at programming and you just don't know where to start to how to solve a problem in a programming language. So that's what we're going to look at today. We're going to look at strategies for solving problems, and we're going to do a sample problem. So the problem we're going to solve today is find the longest increasing subsequence of a list of numbers. Now when you go to solve a problem, the first thing you need to do is make sure that you understand the problem. And if you're working with a customer or your boss or someone else who's giving you this problem, one of the first things that you need to do is resolve ambiguities. So you need to read through the problem and you need to figure out places where there needs to be clarification, and you need to ask clarifying questions. This is great for interviews too. And all this stuff, by the way, takes practice. So the longer you do it, the more often you do it, the better you'll be. So what would be an example of an ambiguity in this problem? Well, one could be the increasing subsequence. What do we mean by that? Because there are actually two different kinds of increasing subsequences. Right? A sequence could be weakly increasing, which means you could have something like this, where you have 1, 2, 2, 3, 4, or it could be strictly increasing, where you have 1, 2, 3, 4. So at weakly increasing, it means that you could have repetitions of a number, but in general, it keeps going upward. Strictly increasing means that there's no repetitions of numbers, that each number is larger than the last one. So that's an example of an ambiguity that you would want to ask your customer, your boss, or your interviewer. So for this problem, we're going to say that we want strictly increasing subsequences. So when you find out this information, you probably want to write it down. So let's write that down. Well, let's say we want strictly increasing. So we want strictly increasing numbers. Another thing that we can ask about is numbers. So what kinds of numbers are these? Are they integers? Are they complex numbers? Are they real numbers? And do they have a specific range, right? Are they only positive? Or are they larger than the machine provided primitives on our machine? So let's say for this example, let's say that we're counting certain things, and we're counting stacks of things or something like that, and they will be positive integers, and they will also be less than or equal to 50,000, since they're stacks of things. So that's great. That means that they'll fit on our machine. And we could even use 32-bit integers if we wanted to. It'll easily fit numbers of 50,000 or less, and we only have to worry about positive integers. So we can maybe use some negative numbers or something for sentinel values. And there's probably some other things in here, but these are just a couple examples of questions that you can ask to clarify your problem, so that way you end up solving the correct problem. So once you feel that you have those clarifying questions out of the way, one of the first things you can do is create some examples of data to wrap your mind around this problem. So one of the easiest things to do is to look at trivial examples. So you can say, okay, well, what if we get, say, an empty list of numbers? Well, that's nice, because we can just return that empty list. It's because it is its own longest increasing subsequence. The same thing holds true for if we have one number. Well, if there's only one number, then that's the longest increasing subsequence of that list. Things start to get more interesting when we have more than one number. So we could have a list that just has an increasing subsequence, which that's easy. We could have something like this. Now this is really interesting because we actually have 4 subsequences, all of the same length, right? So this is we've just found another ambiguity. We could ask whoever gave us this problem that we need to ask them, what should we do if we find longest subsequences that are the same length? Do we care about the first one, the last one, something in between? It depends on the kind of problem that we're solving. So for this example, let's just say that we want the first longest increasing subsequence. So we're going to go for the first one. And then we could have a couple other things, right? There could be many subsequences in here, not just one. So you could have, say, 10, 11, 1, 2, 3. We could have where the longest subsequence is at the beginning, right? So we could have 10, 11, 12, 1, 2. And so this one we have a subsequence at the end. This one it's at the beginning. It could also be in the middle of something. So we could have 10, 11, 12, 7, 8, 9, 10, and 1, 2, 3. Or maybe 1, 2 or something like that. So we have the longest subsequence. It would be 4 in this case. So those are some kind of good examples to look at, and those would actually be good test examples. Once you write your function, you can test them. So one of the first things that you want to do is you want to be able to solve this problem. Besides, we resolved ambiguities. What we've done so far is we've resolved ambiguities and asked clarifying questions. We've written down the clarifications of the problem, and then we've also looked at some sample data. So once we've got some sample data, what we should do is solve the problem without a programming language. If you can't solve the problem without the programming language, then you're not going to be able to solve it with a programming language. Programming languages just make things more difficult. There's more things you have to worry about with individual programming languages. So let's go through one of these and solve it. So for example, let's take this one. It's not so trivial a one. And what we'll do is we'll look at the first number, and we see that, it's the first number. There's really nothing I can compare it to, so maybe we should just remember that number because we want an increasing subsequence, which means we're going to want to compare it to whatever came before. So since there's nothing before the first number, let's just remember that one. So we'll look at the next number, which is 11, and we'll check if it's bigger than our previous number, and it is, so let's remember that. We go to the next one. Now it's smaller than our previous, so what should we do? We want to, this may be the longest subsequence, so we need to remember this somehow. So maybe what we should do is, one thing that we could do is we could actually keep this subsequence. We could have a whole list of subsequences, so every time we get a subsequence, we say, we go to the next one, and we actually save all these numbers. So then we'll save this subsequence, we'll save this subsequence, and then let's once we break our array into all these subsequences, you could find which one is the longest. But that's using kind of a lot of memory. It seems like we could do much better than that, than having to create copies of all these numbers. Because what if we get 1 million numbers and we want to try to find a subsequence? That would use up a lot of memory if we're making copies all over the place. So another way that we could do this is we could say, I know the index that we started, and then when we find one that breaks, we actually know the length, right? So we would know, this sequence starts at 0, and it has a length of 2 once we find a number that breaks the sequence. So maybe that's good. So maybe, if we're going to do that, then we probably need to have a current index, and we're going to have a current length. So as we get current length of 1, and then 2, and then as we go to here, we say, okay, we've broken that sequence and we should save it. And so that means we should probably, as we go along, save the best or the longest subsequence. And the way to save it would be to save the start index and then the length of that sequence. So that way when we go along here, we'd say, okay, this is our new current start sequence, which would start at 0, 1, 2. And we'd say, okay, it has a length of 1. And then we will check the next one and say, okay, that one's good, it's bigger. And then we'll check the next one, okay, it's bigger than the previous. And then we end the list and we say, okay, let's check this current length, which is 3, with the best length that we found, which was 2. Okay, it's bigger, let's save it. So we'll save the longest sequence by saying, okay, we'll save this index, which is 2, and the length of 3. And then once we've reached the end, we can say, okay, let's just return this sequence, which starts at 2 and is of size 3. That seems like it solves the problem for us. And I think it will even solve, it should solve strictly increasing, as long as we just make sure that the next number is greater than and not greater than or equal to. And let's see, it should save the first longest one, right? Because whichever one it ends up being the longest, that one will be the one that we save. Because if we find another sequence that is equal to it, we're not going to save it. We only save the first. So that seems like it should work. So let's just try it out. Let's create, I'm going to actually be using the Go programming language. The programming language doesn't matter. What matters is the strategy that we were using to solve this problem. So as a recap, so far we've read our problem. We've asked questions about that problem, clarifying questions, and we've written down the clarifications to the problem. We've written down some sample data, and then we've also gone through thinking about how we'd solve this without a programming language. What should we do? What steps should we take? So now we're going to take a stab at writing a program to solve the problem. So let's do this, package, main. So we'll just write some boilerplate for our code. We're going to import funct, and let's also create a main function to test what we're going to do. So another thing that's kind of good to do before you just start writing the function is think about how you're going to use the function. So we're probably going to create some sort of sequence, and let's say it's an array of integers, and let's actually use let's use this example here, like this 10, 11, 12, 1, 2. So 10, 11, 12, 1, 2. So we'll test that one. And then we'll have, say, an answer, and it will be our longest increasing subsequence. And we'll give it a sequence. And it looks like that would be the best way to use it. So we'll feed it a sequence, and then we'll get an answer out for the actual sequence that we're looking at. And then at the end, we'll print out our answer. So we'll print out answer. That seems like a pretty good use for it. So let's go ahead and start writing our function, and it will have this name here, and it will take a sequence of integers, and we're going to return. Actually, in Go, it's called a slice of integers, so we'll return a slice. And so let's think about this. What were the variables that we were keeping track of? Well, we had a current index, which let's just set it to 0 for now. We had a current length, which will start out at 0. We had a best index. We'll say it's 0, and a best length, which we'll set to 0. And then we also had a previous number. We were remembering our previous number. So let's do that. In fact, let's see, let's set it to -1 so that way we know that we don't have a previous number yet. And let's see, we know that we're only going to have to go through our list once. So we could probably do this in a loop. So let's create a loop where we have I, which is the index of our number, and we'll have a number, which is our current number. And let's range over our sequence. Now what we can do is we can check. Let's see. So yeah, we can check. There's a couple things that we could do here. We could either have this loop like it is right now, or we could have the regular kind of for loop where we have I equals 1, and we could prime the loop beforehand. But let's just have an if statement here. So let's say if previous number equals -1, then what we'll do is we know that this is our first time around, so we'll say that our current index will equal I, and we know that our current length will equal 1. And then let's see, then we'll say our previous number will equal our number. Right? Now, otherwise, if it's not the first time around, then what we'll do is we need to check if, let's see, what will happen? We need to check, let's see, what are we doing here? So we're going through each of these numbers. Oh yeah, we need to check if our current number is greater than our previous number. Right? So, and if it is, then we know we can continue on, right? So we can say that current length, we can add 1 to it, and that's good. And we can also say our previous number equals number. Otherwise, if the number is not greater than the previous number, we know that our sequence has ended. So what we can do is we need to check and see if our current length is greater than our best length. And if it is, then we need to save our index. So we'll say best index equals the current index, and best length equals current length. There we go. And what we'll do now is we will say that current index now equals the index that we're currently at. So we'll start a new sequence. And the current length should be 0 now. All right, so now if it's, let's see, so we know that it is a new sequence, right? If it's not, so if it's not, if the current length is not better than, then what should we do? Oh, actually, what we should do, let's see, best index, current index, we should save that. And really, this happens no matter what. So we can do this. There, so that happens no matter what. And then what we'll do is, after we're done, what we should do is, if we think about this, okay, let's say we go through with our 10, 11, 12, 1, 2. Let's say we get, our first number comes in, it's a 10. So our previous number is -1. Then our current index will be 0. Our current length will be 1. And our previous number will be 10. Right? Now we'll go through our loop, and then we'll have 11, So we'll go to this else statement, and 11 is greater than our previous number. So current length will now be 2. Our previous number will be 11. We go around again, and it's 12. So current length equals 3. Previous number equals previous number equals 12. Yeah, previous number equals 12. We go back around again, and we have, say, a 1, and then it will save, right? It'll also go, so it won't be greater than, and then it'll save. So that's good. But think about, what if it was at the end? What if we had this 10, 11, and then 1, 2, 3? Well, we'd have 10, 11, and it would save it. But then if we do 1, 2, 3, and it ends the for loop, and we never go into here, then we'll never save. So what we need to do is we actually need to save we need to check if we need to save. So we can say if current length is greater than best length, then we'll do the same kind of save. So best index equals current index, and best length equals current length. There we go. And then we can just return the part of our sequence that matches that the sequence. So we go current index, or best index, and we need to go to best index plus best length. I think that's how it'll work. And so it seems like we're done. So once you have a function in place, then it's good to test. So if you're doing professional software, then you probably want to write some unit tests for this function. If you're in an interview, you'll want to go by hand on a whiteboard or something similar and go through a couple of these examples by hand and see if follow your lines of code and see if it works. Or you can do what we do here. We're just going to create a few examples and run them and see if they work. So let's go ahead and run this and see if we get the answer that we're looking for. Now the answer that we're looking for should be 10, 11, and 12, I think. So, and that's what we got. So we got 10, 11, and 12, so that's good. Let's test if it's now this is another thing you have to think about, is you need to test to make sure if you do all of these requirements here. So we need to make sure that it gets strictly increasing subsequences. So let's create a subsequence 1, 2, 1, 2, 2, 3. So this one, if it was getting weakly increasing ones, it should be 1, 2, 2, 3. If it gets strictly increasing ones, then it should just get the 1, 2 because it looks for the first one. So let's run it again, and we get 1, 2, so that's good. So it's strictly increasing, that's great. Positive integers less than or equal to 50,000. This is actually, we're guaranteed that it's going to be like this, so that's good. So we don't have to worry about that. We want the first longest increasing subsequence. So let's create some subsequences. We've already kind of tested that here, but let's do it again. Say 10, 11, 12, and 1, 57, 98. All right, so now we have two increasing subsequences that are both of size 3, so we should get the first one. So let's check that, and we get 1, wait, I didn't save, here we go. So we got 10, 11, 12, which is what we expected, so that's good. So let's try this example here, where we have 10, 11, 12, where our subsequence is actually in the middle. 10, 11, 12, 7, 8, 9, 10, 1, 2. So what we should get here is we have a subsequence here, we have a subsequence here, and we have one here. But the longest one is in the middle. So we should get 7, 8, 9, and 10. Oh, did I save properly? Let's see. I think I did. Oh no. So it looks like we didn't. Looks like we got 10, 11, and 12. So it looks like we have a bug. So there's several different ways. So when you have a bug, there are several different ways to do things. You could set breakpoints, you can have logging and all that. One of the old school ways of doing it, which is what we're going to do here, is you can just use print statements to see what's going on inside of your code. And then once you get visibility into what's going on inside your code, then you can usually figure out what's going on and fix it. And so we want to find out where the problem is. So what it's doing is it's saving 10, 11, 12, but it doesn't seem to be finding 7, 8, 9, and 10. It's not recognizing that 7, 8, 9, and 10 is a longer subsequence. So that means, in fact, I may not even need to use any print statements. I bet it's when we're saving it here, our length probably doesn't need to be 0. It needs to be 1 because we're starting at we're starting a new sequence right away. If we started at 0 here, we're already at a sequence number, and if we go again, the sequence should be 2 long, not 1 long. So let's see if this makes the difference. So no, it didn't seem to make a difference. It seems like there's still a bug. So we need to figure out what we're doing incorrectly. So what we'll do is we shall create some print statements to see what's going on. And where it's breaking is when we get a new sequence. So let's check here. New sequence. And what we're going to do is we're going to say let's print out the new length and the best length, so that way we can check what's going on. So we'll print F and we'll say new length, and it'll be a number, best length, number, cur length, best length. Actually, I guess this will be the current length. So this will give us an idea of what our current length and our best length is when we get a new sequence. So maybe we're not getting the right number. So we have a new sequence, current length is 3, best length is 0, so we should be saving that sequence. So this is telling us that this was telling us that our current length was 3, so that's good. So, but the next one should be 4. So let's see. So then the current length, 1, best length is 3. So what is it? Why is it? Seems like it's getting a new sequence every time here. Oh, that's because our previous number. Okay, so here we found out our problem. So we should set our previous number to our number because we're starting a new sequence. In fact, we know we're going to be starting a new sequence, so we set it here. This may fix our problem. Ah, and it did. So that is an example of when something goes wrong, you can use print statements to kind of figure out what's going on inside the program. And when it gives you that visibility, you can figure things out. So in this case, we forgot to set our previous number to the number. And now it looks like our program seems to be working. So that is a short and kind of simple introduction to problem solving in computer science. I guess as a recap, you read the problem, you try to unambiguate different things by asking clarifying questions. You write down the information that you get from those clarifying questions. You try out some sample data, or you write down some sample data to help visualize the problem in your mind. Then you solve one or more of those problems by hand without code. And then you can code your solution, and then you test your solution. Now, a couple tests that we should probably do is we should test with the empty list, right? So we should get the empty list back if it's empty, and it does, so that's good. And what happens if we give it one number? We should get one number back, and that's good. And of course, if we have two different numbers, it should give us the first one because we want the first longest subsequence. And we do. So that's good. Thanks for watching, people. Till next time.